chemical bonding. The smallest particle of matter which is present in the universe, which has independent existence, is called molecule. So, molecule is the smallest particle of the matter present in the universe which has independent existence. For example, helium, He, H2 molecule, CH4 molecule, NaCl molecule, so on. The attraction force acting among the atoms or ions which kept them together results in the formation of molecule. That attraction forces, they are called chemical bonding. Zero group elements, they are monoatomic molecules and they are stable. If I ask helium, its atom formula He, molecule also He. Hence it is called monoatomic molecule, which include helium, neon, argon, krypton, xenon, radon, and they do not participate in chemical reactions. That is, they are chemically inert. Why? And the rest of the elements other than noble gases, they are chemically. Some elements are less reactive, some are moderately reactive, some are rapidly, they participate vigorously in the reaction. Why? What is the reason? And what is the significance of chemical reaction? What for chemical reaction? So, chemical reaction, it occurs from unstable reactants to stable products. To explain all these phenomena, scientists forwarded several theories which include theory of electrovalency, theory of valency, valency shell electron pair repulsion theory, molecular orbital theory. Theory of electrovalency given by Kossel and Lewis. Main postulates: chemical species having 8 electrons in the valency shell, that is 8 valency electrons, are said to possess octet and they obey octet rule, results in stability. So, chemical species having 8 valence electrons, that is 8 electrons in the outermost orbit, are said to have octet, obey octet rule, results in stability. Example, except helium, the remaining noble gases, they have octet. In the outer shell, they have NH2, NP6. For example, neon, 2s2, 2p6, argon, 3s2, 3p6, krypton, 4s2, 4p6, xenon, 5s2, 5p6, radon, 6s2, 6p6, and oganesson, 7s2, 7p6. They have octet, they obey octet rule, hence they are stable, hence they are chemically inert. Elements such as sodium, magnesium, by giving electrons, for example, sodium, it has 11 electrons, that is 281 electron configuration. By giving this extra electron out, we have 28. This 8 is nothing but 2s2, 2p6. So, stable. Mg, 282, 12 electrons totally. Extra, it has got 2 electrons. By losing these 2 electrons, it is now 28 having octet. Stability. So, elements such as sodium, magnesium, aluminum, by giving electrons, they are getting octet, obey octet rule, results in stability. Similarly, elements such as fluorine, oxygen, nitrogen, by accepting electrons, for example, fluorine 2, 7, by accepting 1 electron, 7 plus 1, it becomes 8, that is 2, 8, octet. Oxygen 2, 6, atom number 8. So, this 6 electrons plus 2, accepting 2, it has now 2, 8, that means it has octet, obeys octet rule. So, elements such as sodium, magnesium, aluminum by giving electrons. Elements such as fluorine, oxygen, nitrogen by taking electrons, they are getting octet. Obeying octet rule results in stability. Elements such as carbon, so it has atomic number 6, electron configuration 2, 4. It has got only 4 electrons in the outer shell. So carbon having 4 electrons, 1, 2, 3, 4 electrons in the outer shell, from H taking 1, H taking 1, H taking 1, H taking 1. So originally carbon 4 valence electrons and taking 4 electrons from 4 hydrogen atoms, totally getting octet, thereby stability. Likewise nitrogen, it has 5 valence electrons, 1, 2, 3, 4, 5 valence electrons, and H contributes 1, H contributes 1, H contributes 1. Originally nitrogen 5 valency from 3 hydrogens, 3 electrons totally. Likewise oxygen 2, 6, it has 6 valence electrons, 1, 2, 3, 4, 5, 6, and H contributing 1 electron to this unpaired. So H again giving 1 electron to this unpaired up. So now oxygen 6 valence electrons, extra 2 electrons from 2 hydrogen atoms, it has octet. That means elements such as carbon, nitrogen, oxygen, by sharing electrons, they are getting octet, thereby stability. Species which obey octet rule. F 7 valence electrons, extra 1, that is minus 1, 8 valency. Oxygen 6 valence electrons, extra 2 electrons, 6 plus 2, 8, octet. N 5 valence electrons, extra 3 electrons, 5 plus 3, 8. Carbon 4 valence electrons, extra 4 electrons, 4 plus 4, 8. And sodium, actually it is 2, 8, 1 by losing 1 electron, so plus 1, it is octet. Mg 2, 8, 2 by losing these 2 electrons, it is now plus 2, having octet. O 6 valence electrons, H gives 1 electron for bonding and extra 1 electron, minus 1 means extra 1 electron, 8 obeys octet rule. N 5 valency, 2HS2, extra minus 1, extra 1, 8 valence electrons, octet. Carbon 4 valence electrons, 3HS3, extra 1 electron, octet. S 6 valence electrons, extra 2 electrons, octet. Chlorine 7 valence electrons, extra 1, octet. S 6 valence electrons, H 1 electron, extra 1 electron minus 1, that is octet. They obey octet rule. Likewise N 5 valence electrons, 3HS3, totally 8, obeys octet. Oxygen 6 valence electrons, hydrogen 2, that is octet. F 7 valence electrons, H 1, octet. P 5 valence electrons, 3 chlorines, they contribute 3 electrons, octet. They obey octet rule. Molecules such as BF3, boron 3 valence electrons and 3 Fs, they are contributing 3, totally it has got 6, no octet. PCl5, phosphorus 5 valence electrons, 5 chlorines, they are contributing 5 electrons, total 10 electrons. Then SF6, S 6 valence electrons, 6 Fs contributing 6, totally 12. And IF7, I 7 valence electrons, 7 Fs, 7 contribute, totally 14. So these molecules BF3, PCl5, SF6, they are not obeying octet rule. Even though these molecules are not obeying octet rule, they are stable. So-called theory of electrovalency could not explain the stability of molecules such as BF3, PCl5, SF6, IF7, which are not obeying octet rule. This is the defect of theory of electrovalency.